Yeah, this is Joy in Mathematics. Let's continue on vectors. Now we want to learn on angle between two vectors. So we might have a vector A in this direction. We can have another vector B in this direction, and we have to evaluate the angle theta. So let's recall on scalar product and vector product, the formulas, because that's how we'll get to evaluate the angle between the two vectors. Scalar product A dot B, we have it to give magnitude of A multiplied by magnitude of B cos theta. And as well for the vector product, we have that A cos B is equals to magnitude of A magnitude of B sine theta. Okay, now if we go from scalar product, we can evaluate that A dot B, if you divide both sides by magnitude of A magnitude of B, we'll have this to be cos theta. Therefore theta will be arc sine A dot B divided by magnitude of A magnitude of B. And as well, if we go from the vector product, we have that A cross B, the magnitude of A cross B divided by modulus of or magnitude of A and magnitude of B is equals to sine theta. Therefore theta will be arc sine magnitude of A cross B divided by magnitude of A and magnitude of B. So we'll be applying all these two formulas from scalar products, from vector products, and we'll implement it in both 2D and 3D vectors. Let's begin with two-dimensional vectors. We are given two vectors A is equals to I plus J, and B is equals to I minus J, and we are asked to evaluate the angle between them. Most of the times we use the scalar product. This is mostly used to evaluate the angle between the two vectors, but we will use the two so that we'll be able to compare our answers. So let's begin. The first thing we will evaluate is magnitude of A. Magnitude of A will be the square root. Let's move this. The magnitude of A will be the square root of 1 squared plus 1 squared. That's the square root of 1 plus 1, which is root 2. Likewise, the magnitude of B is the square root of 1 squared plus minus 1 squared, which will be the square root of 1 also plus 1, which is also equals to what? Root 2. Now the next thing to evaluate is A dot B, since we are dealing with scalar products. Let's demarcate it using scalar products. We know that A dot B is equals to modulus of A modulus of B cos theta. Okay, now the next thing to do is to evaluate modulus A dot B. So let's move this aside and let's evaluate A dot B. Evaluating A dot B now, we are going to have 1 multiplied by 1 plus 1 multiplied by minus 1. So we have 1 multiplied by 1 and plus 1 multiplied by minus 1. Therefore, we have that A dot B is equals to 1 minus 1, which is equals to 0. Now with this, we have that A dot B is equals to 0. Modulus of A is equals to root 2. Modulus of B is also equals to root 2. Now we can come from the formula given in this place of scalar products and say that since A dot B is equals to magnitude of A multiplied by the magnitude of B cos theta, if we divide both sides by magnitude of A magnitude of B, magnitude of A magnitude of B, then we'll be left that A dot B divided by the magnitude of A and magnitude of B is equals to cos theta. So A dot B is equals to 0 as we have here. Magnitude of A is root 2. Magnitude of B is also root 2. Cos theta. So now we can say that cos theta therefore is equals to 0 divided by, applying rules of swords here, we have 2 multiplied by 2. That's 0 divided by root 4, which is 0 divided by 2. Now, if 0 divided by 2, if we evaluate that, it gives us 0. So theta will be inverse cos or a cos of 0, and theta is equals to 90 degrees. So now we are able to evaluate the angle between the two vectors, given that A is equals to I plus j and B is equals to I minus j. We can see that the angle between the two vectors is 90 degrees. That means A and B, okay, are perpendicular to each other. Now this is just a basic example. Now let's move on to the next. Let's take another example. Let's say question 2. We are given that A, or this time let's use X, is equals to 2I plus 3J, and Y is equals to minus I plus 4J. We're asked to evaluate the angle between the two vectors. Let's use dot scalar product still. Scalar products. So scalar products here will be x dot y is equals to the modulus of x modulus of y cos theta. So let's begin with the modulus of x, or the magnitude of x, will be equal to 2 squared plus 3 squared, and that will give us root 4 plus 9, that's root 13. Likewise, magnitude of y, square root of minus 1 squared plus 4 squared, and that will be square root of 1 plus 8 plus 16 rather, and this will give us root 17. Moving on, let's evaluate x dot y. In x dot y, we are just going to multiply the coefficients of I and add it to the multiplication of the coefficients of j. So this will result into 2 multiplied by minus 1 plus 3 multiplied by 4. So with that, we have minus 2 plus 12, and this will result into 10. So we have x dot y to be equals to 10, modulus of x, okay, is equals to root 13, modulus of y, or magnitude of y, is equals to root 17. Then we can evaluate our theta. So from x dot y is equals to modulus of x modulus of y cos theta, we can say that cos theta is equals to x dot y divided by the magnitude of x, or modulus of x, multiplied by the magnitude of y. So this will result into 10 divided by the magnitude of x is root 13, and the magnitude of y is root 17. Alright, so let's use our calculator there. So we have 10 divided by root 13 multiplied by root 17, and this will give us 0.6727. Now we can evaluate our theta. So therefore theta will be equals to inverse cos of 0.6727, and this will result into 47.73 degrees. So now we have been able to evaluate the angle between the two products, the two vectors x and y, as 47.73 degrees.